All right, so I'm going to make a series of videos, probably just doing 4 or 5 different problems, discussing the systems, different ways to solve systems of equations and the methods that we've learned. So the first video is really going to be focusing on the elimination method, and I'm going to put 2 together for that, and then I'll just upload everything for you guys on my big campus. So far we have learned 2 ways to solve systems. We have graphing, and then we have the substitution method. Now, graphing is great when you have whole number coefficients, but it doesn't work well with decimals. So it's not good for decimals or when you have fractions. And I want you to know that that's why there are different methods. Okay, so it's not good for decimals or fractions. So today we're going to talk about the elimination method. So the steps, first of all, we want to write the equation in standard form so that the variables are lined up. And then we need to eliminate one of those variables, and we're going to do that using addition or subtraction. We always eliminate the variables that have the same coefficient, okay? And then we're going to solve for the values of the variables. The last thing that we need to do is make sure that we check our solution, and that's something that we didn't focus on because the video I had you watch on Tuesday didn't focus on that, but we're going to make sure that we do that. So let's look at our first example. My first example is x equals 2y plus 14 and 3y equals negative x plus 9. So we want our equations to be in standard form, and if you remember, standard form is ax plus by equals c. So I need to do some moving around on these 2 equations. So that's what I'm going to do first. I'm going to subtract 2y, or I'm going to move the 2y over. And so when I do that, I have x minus 2y equals 14. That's for the first equation. And on the second equation, I need to move this guy over here. So that's going to look like x plus 3y equals 9. All right, so I have both of my variables, or both of my equations in standard form. So now I'm going to line them up, and by that I'm just going to take this and put it under here. So really I'm going to rewrite them as x minus 2y equals 14 and x plus 3y equals 9. Okay, so we are using the elimination method, meaning we're going to eliminate one of the variables using addition or subtraction. So hopefully you see that I have these 2 variables, my x terms, have the same coefficient, a coefficient of 1. So I want to eliminate them, and I'm going to do that by using subtraction. So really I'm going to subtract x from x minus x. So x minus x is 0x, and we don't write that, so it's really nothing. Now I have to focus on this piece. I have a negative 2y minus 3y. Negative 2y minus 3y equals a negative 5y. And I have 14 minus 9, and that equals 5. Just divide both sides by a negative 5. And I see that y equals a negative 1. Okay? So now that I have that, I'm going to take this value of y, and I'm going to plug it back into either one of these original equations. And I'm going to put it right here. So x equals 2 times a negative 1 plus 14. X equals a negative 2 plus 14. X equals 12. So my solution to this system is the ordered pair 12, negative 1. Now I need to check those, and I need to check it in both equations. So I have the equation x equals 2y plus 14, and I have the equation 3y equals negative x plus 9. I want my solution to work for both of the equations in my system. So I'm just going to plug in the values. 12 equals 2 times negative 1 plus 14. 12 equals a negative 2 plus 14. 12 equals 12. That checks. 3 times negative 1 equals a negative x, or negative 12 plus 9. Negative 3 equals negative 3. That also checks. So this is the solution. Okay?